In this video, we will learn how to use the Cramer's rule in solving a system of equations. The question is like this. Use Cramer's rule to solve the system of equations given below. That is 2x1 plus 4x1 is equal to 16, 3x1 plus 5x2 is equal to minus 9. We have to find the value of x1 and x2 here, okay, using Cramer's rule. So, how do we solve it for the Cramer's rule? First, we write the given system of equations in matrix form. That is, we write them in the form of Ax is equal to B. Okay, this A is the coefficient matrix. This X is the solution vector, the solution which we want to find, and B is the vector of constant terms. Okay, so what is A is the coefficients of x's and x1 and x2. So here the coefficient of x1 is 2. I will write here 2. Coefficient of it is here x2. Coefficient of x2 is 4. I will write here 4. Coefficient of x1 is 3. Coefficient of x2 is 5. Okay, this is our A. Our x would be equal to, that is x1 and x2, which we have to find. And our B is the vector of constant terms, that is 16 and minus 9. Okay, now to find the value of x1, what we will do, to find the value of x1, we replace the first column of the coefficient matrix with the column of with the vector of constant terms. Okay, let me use another color here to make it more clear to you. We have 16 and minus 9. I repeat, to find the value of the x1, we form another matrix, let us say A1, in such a way that we replace the first column of the coefficient matrix with the vector of constant terms. So I will write here, to find x1, we form new matrix, let us say A1, in such a way, or I will write, I'm not so good in English. So to find the value of x1, we form new matrix A1 by replacing first column of coefficient matrix, that is A, with vector of constant term, which is B here. Okay, and one important thing that I forgot to write first we have to take the determinant of this very matrix. Okay, so I apologize for that. So the determinant of this very matrix is given by, we multiply the principal diagonal elements, that is 2 and 5, that is 2 into 5, and from that we subtract the product of these very elements, that is 3 into 4. So here we have 2 5s are 10, 3 4s are 12, and A is equal to minus 2, which is not equal to 0. If the determinant was equal to 0, then the system of equations was not feasible. We will not have been able to solve the given system of equations. Okay, since the determinant is not equal to 0, so we can say that the solution exists. So I will say solution exists. This was the very important point that I forgot to write in the first place. Okay, so first thing is, we take the determinant of the coefficient matrix, and if it is 0, then we cannot proceed further. If it is not, then we can find the new matrix. Okay, so to find the value of x1, now we form new matrix A1 in such a way by replacing the first column of the coefficient matrix with the vector of constant terms. So our A1 is equal to, this will be equal to So 2 3 are replaced by 16, 16 minus 9, and we have 4 and 5. Okay, this is our new matrix, and then we take its determinant. Okay, determinant of a1 would be simply as we have shown here, 16 into 5. So what is 16? 16 into 5 is 80, so I will not write here. So 16 into 5, I will write here 16 into 5. Minus is from the formula, then we have minus 9 into 4. Okay, so this comes out to be 16 into 5 is 80 plus 36, 9 4 are 36, this comes out to be 116. Okay, then what would be the value of x1? X1 is equal to the determinant of the new matrix divided by the determinant of the coefficient matrix. What is the determinant of this very new matrix? This is 116 divided by what was our determinant of the coefficient matrix? That was minus 2. So this comes out to be 58. Okay, so this is how we find x1. Similarly, if we want to find the value of x2, in this case we replace the second column of the coefficient matrix with the vector of constant terms and take the determinant of the remaining element, remaining matrix. Okay, so new will be, I will not write this very step here. So new matrix a2 will be formed by replacing the second column of the coefficient matrix with the vector of constant terms. Okay, so it is to be remember, first if we want to find the value of x1, we replace first column. If we want to find the value of x2, we replace the second column. So if similarly, if it was here x3, then we would replace the third column of the coefficient matrix. So our new matrix here would be 2 3, and in place of 4 and 5 we write 16 and minus 9 and take the determinant. Now what is the determinant of a2? Similarly, 2 into minus 9, 2 into minus 9 minus 3 into 16, which comes out to be minus 18. 6 into 48, 16 into 3 is 48, which comes out to be minus 66. Then the value of x2 is simply x2 is equal to the new coefficient, this new matrix divided by the determinant of the coefficient matrix. So determinant of a2 is 66, minus 66 divided by the determinant of a is minus 2. So this minus minus gets cancelled, we get 33. So x1 is equal to 33, and x2 is equal to 33, and our x1 is 58. I hope I make myself clear. Actually, I have made detailed videos on the Cramer's rule. You can check my playlist on matrix algebra and economics. You will find the whole lot of stuff there. Thank you.